得给我们一个。
我知道。
Good morning. Welcome to the last day of Halves. There's 7 teams today that are presenting their progress, their plans for the rest of the semester. I'll be keeping track of your times to watch for me. And teams who are here, remember you're expected to stay here for the whole session. We're all be good audience members for all the teams presenting today. And people on the stream watching, enjoy. With that, quest makers, you're up.
Okay, good morning, everyone. We're on the level design production project, and our team name is Questmaker. On our team, we have Jingyi, Mike, Vishal, Polly, Xuan, Tianyi, and Luis. Our instructors are Ruth and Ricardo. Our SME is Katul. In this presentation, we're dividing our content into 4 chapters. Firstly, we're going to talk about our goals, challenges, and success, following by a short video demo. After that, we're going to talk about our design and production, and lastly, playtest and iteration. So this project aimed to create a design of one in-game level of a third-person action adventure game with a layer of polish. The purpose of it is to explore level design in a professional industry standard pipeline. We design, iterate, and polish under a professional level designer's guidance, which is our SME, by getting regular guidance and feedback. And the end deliverable should be a piece of level design that is portfolio worthy. And to understand the work we're doing, it's important to know the key difference between level design and game slice. A vertical slice is a portion of game that acts as a proof of concept, which might include system, narrative, mechanic, and art, even sound, to show a slice of a fully functional game. Level design, on the other hand, is the practice of planning and building space for a video game, which comes after establishing some fundamental. In our case, it means building enough narrative, system, mechanic, and assets to demonstrate gameplay of one quest within a 3D space. With very few constraints, here are some of the difficulty we faced. When planning for an action-adventure game, the scope can easily get out of hand. To form a reasonable scope, we decided to prioritize the strength of our team and use our specialty in a way to enhance the player experience and let the design intention come through. This also means we're minimalizing aspects such as UI and sound design in this level. We also needed a decent foundation to even start level design. So by quickly making decisions during brainstorming and pre-production phase, we're able to start prototyping right after quarter. To create a third-person adventure game level, we also needed a character. But having no character animator or artist, we decided to take advantage of Unreal Marketplace. Planning and designing based on available assets to us was helpful in this situation. After a few discussions with our SME and our instructors, here's the list of measurement of success. Level design pipeline isn't a fixed formula in every studio, so with a deeper understanding of our team structure, we are creating a unique pipeline that works for us. Our end deliverable should prove the sturdiness of this pipeline, and our documentation should reflect the adjustment we made along the way. Our team also has the skill to create a layer of polish that's not normally seen in level design projects. Our deliverable should have everybody's work implemented in a way that's enhancing the designed experience and successfully show this layer of polish. Defining what polish means to us was very important, and we'll be presenting this information with more details in part 3 of this presentation.
So now I'll be talking about what we have right now in terms of the demo. So we have the character's movement abilities and attack abilities that already feel magical to the player when we play tested with some players. We have our enemies that provide adequate challenge to the player for a good intensity curve. As you can see here is the demo for the enemies. We have a vision change ability that is intended to feel impactful and powerful to the player. And here is a corner of our level that is fully polished with 3D environment art. And we intend to have 2 acts that will be polished like this in terms of environment art at the end of the semester. And we'll have assets from these assets that we made for this 2 acts that will be placed in all the parts of the level. So moving on to what is the goal of the level. The goal for the player is to find and destroy the remains of otherworldly magic in the civilization that they are going in. And the other goal for the player is to find out more about their past, and which is the past where they were a god of nature. And so why would the player want to do it? So the motivation for the player is narratively because the otherworldly magic is dangerous to the world and the world needs saving. And the second part is that you have visions from your past that you need to find out more about, and that is a personal motivation for the player. Now, how does player achieve this goal? So in addition to having main goals for the level, there are several small goals that incentivize the player to play through the level and finish the journey. So we divided the level into 8 different parts, and with a total gameplay time of 18 minutes. So each of these acts has a combination of these 4 elements, that is puzzle, exploration, vista, and combat. So here is a pacing graph for the level. So the player starts here as Act 1, and the Act 1 and 2 are traversal acts where the player is doing exploration. The second act has an important landmark that the player should feel as important, and it is visually, like literally and narratively connected to the 4th act and the 6th act. The 3rd act is a stealth and light combat act, which will then move on to the 4th act, where the player will be introduced to a new mechanic. And before that, the player will have to solve a puzzle to get a build-up for that new mechanic that they will be getting. And the fifth act is a platforming / traversal act, but it will be more challenging because there will be combat there. And at the 6th act is where there will be a major lore reveal. So the player will come to know more about the story, but it is not very intense in terms of pacing. And the 7th act is where the player will fight a boss. So it is a very intense act. And after that, the player will complete the goal by destroying a statue. That is the 8th act. And our level is set in the middle of the game. So there is not much context that the player has regarding the level. So we are making a gym level to train the player and the mechanics that would have already been taught to them if the level was part of the game. And so the gym level will help them to master all the combat, the movement mechanics, and the interactions. Moving on to the gameplay programming.
Okay, so for the character, the gameplay is divided into 3 parts: moving abilities, skills, and interactions. The first part is moving abilities. Our character has these abilities, and that is the ability that we want our players to enjoy the most, as it can make them to move fast to any direction in the map. These abilities decide how the character can move around in the map, and this helps our designers to decide how to block out for our level. We have 2 kinds of skills: combat skills and exploring skills. Players will use combat skills to deal damage to enemies and destroy obstacles in the scene, and they can use exploring skills to solve puzzles and explore the map. All these skills are supporting our whole combat design and puzzle design, and we want to introduce one of the skills vision change as a new mechanic to the players. Our interactions mainly has the collectible system and dialogue system. Collectible stuff in the map can give motivation for players to explore the map, and dialogue system can provide extra information for narrative design.
Well, I'm going to talk about the fun part, which is the enemies the player is going to fight with. As an action RPG game, the combat systems is crucial to our level design foundation, and there wouldn't be a combat system without enemies. Here's the general behavior of the enemies to make them smart. So All of them has 3 different senses: sight, hearing, and sense to damage. They will start off, there are also 4 states. They will start off in the passive state. This is where they patrol around an area with the patrol routes set by our level designers. When they hear a noise or they're being attacked by the player without knowing where the player is, they will enter the investigating state, which is where they are going to try to search for the player. When they see the player, they go into the combat state. This is where they go out to attack the player. And finally, when they feel they're currently being overpowered by the player, they will each individually take different actions to take cover or disengage for a better chance of defeating the player. Next is their movement and special reactions. Here's an image of the mage enemy trying to find its most optimal spot to hit the player with its next spell cast. So all the spots are the possible movements, and I implemented algorithms to allow them to search for the most optimal point within good efficiency. Next is their special reactions. This depends on the enemy types. For example, the boss enemies has summoning abilities to summon minions when its health is low to distract the player, while the mage enemy has teleporting ability to dodge the player most important spells as shown in the demo video. Next is the combat design and optimization. For the combat, I implemented a mechanic where only 2 enemies are allowed to attack the player at the same time. This is to serve the purpose of level design to allow us to put more enemies on the same thing without overwhelming the player by the number of attacks per second happening. I also did some stats balancing to make sure the player receives appropriate challenge. For the optimization, I implemented the method of pruning as well as avoid using the more expensive per tick calls. Next.
These are how we define as polished for programming. So to sum up, before Halves, we have implemented all the gameplay and enemy system functions to make our game playable. And after Halves, we will focus on polishing to make sure our gameplay can support all the mechanics and designs for our level design. Then we move to the 3D environment.
So as you can see, the key elements of our entire scene is the magic. So our team draw the references from the lost civilization of Atlantis. So it will basically be the underwater ruins of the civilizations that will think under the sea. But we also modified based on our mechanics and also the narrative design. So the entire scene will be surrounded by the magical boundary, so there will be no water in the sea. But you can see the bluish styles, so it will be surrounded by the water. In order to further refine our visuals and also to facilitate the asset creations for our environmental artists, we have created the references for the ancient Greek and Roman style architectures, not only because this can show the grandness and also the epicness of our entire scene, but also we can draw a lot of real life photos to facilitate the asset creations. So here is a prop list I have already completed before the half for the basic scene setup. It includes several elements like the bedrocks, the stones, the trims, and etc. And in order to show the bluish styles of the entire scene, I have also created an underwater blueprint and also the corresponding skyboxes to simulate the real underwater lighting effects. So it will mainly simulate the real reflection of the water body. So you can see there's a bloom and also the bluish overall styles. In order to show my definition of the polish as an environmental artist for this project, I have created the demo polished demo of a portion of the Act 1 map. So as you can see, it started with the gray box, and then I completed the main body, which is the temple in the middle. And then after I confirmed with our level designers to confirm the scales and as well as the positions of each building block, I finished the polished version of that section. Since we only have one environmental artist in the team, so we have discussed with our SME and also instructors that we will mainly polish the two maps out of the 7, but this is a degree that how I define the polish. And this is another part of the floating sections. I use that in examples for the definition of polish.
As technical artists, our mission is to deliver the team's vision technically and artistically. We work closely with our programmer and designer to implement visual effects that creating an immersive and engaging world, aiming to visually enhance our gameplay experience and also communicate important information to players, such as providing feedbacks when abilities are used and offering visual clues for level guidance.
For example, there's 3 ice attack effects, and the first one is line attack, the second one is AoE attack, and the third one is basic attack, which throws ice projectiles to the enemies. So this will be the first kind of element magic the player will use when they enter into the world. And here is our definition of polished for tech art. First, we want to achieve the design intention with a good look visually and also help to tell the story. And second, we want to fit in the whole environment by working closely with our environment artists. And finally, because visual effects are usually costly, so we will make sure that they will run smoothly in the game.
In this project, we have the luxury to decide what our target audience is, which is players between the age of 15 to 50 who enjoy action-adventure genre. We created a sprint schedule that allows us to build, every other week on Tuesday for playtest night. We're recording every playtest session to gather player data on behavior and feedback for future iteration. We have weekly meeting with our SME as well. Here's a clip of our SME giving us feedback.
The challenge you're presenting them, and they
He's
should be
giving
able
us
to figure.
feedback. Working closely with our SMEs, helping us locate the flaws in our level design and mechanics, and his feedback is helping us create a cleaner and more professional look in our design. His input plays a significant role in the pipeline, which help us achieve our end goal. Here's a look into our future schedule. We're now open for questions. Thank you.
So I understood your demographic of 15 to 50, but what about player experience? Do you want, is this for really experienced players and maybe 10% will succeed in 18 minutes? Or are you going to have different difficulty levels where this will work for novices to expert and maybe we can choose if we're novice, middle, or expert?
So we'll be targeting for novice players that are not, so you don't require a lot of like combat skills or movement skills like in terms of controlling the player. However, we'll try to make it such that you can use a controller and thereby you can quickly grasp the control. So the gym level will be helping in training the players to do that.
And I would like to add up for the combat system. So I actually have a dynamically balancing difficulty. So this is where if the player dies in the same scene to the enemy for multiple times, I will sense that you suck at the game, and then I will try to lower at difficulties.
Thank you.
Hi guys, this is Team Air Mixery, and up on the stage we have our team members Zibo, Xinyu, Penghua, Zhiying, Anton, and Marsh. And we are a team of 6, and our instructors are Mike Crystal and Scott Stevens. We also have our client, Anthony Rowe, who's from the CSE department of CMU. He's also one of the members from the West Lab. West Lab developed a platform called Arena, and we'll be developing our experience in Arena. So what is Arena? Arena is a web-based open source platform that supports a collaborative mixed reality tool, and we will also be using this tool during our experience. It specifies in two major aspects of collaboration and also multi-user aspect. Besides our client, we also have our consultant, Anthony, and also John Troy to help us support our technical issues in Arena. We also have Shirley Yi as our SME to help us on our research in Chinatown, Pittsburgh. So for our project, we treasure three important aspects called documentation, playtesting, and also prototyping and storytelling. Among all the project matrices, we'll be further develop those aspects in our experience. So that brought us to our goal of creating a demo of Chinatown, Pittsburgh, which maximize Arena's capability in three ways. First of all, storytelling, multi-user aspect, and also AR/VR experience. And what counts as our success is we'll be creating this experience in Arena, and we'll be developing and improve Arena platform. And as a goal, we'll also want to draw attention to the content user in the use of Arena. And I will hand to Anton of why we choose Pittsburgh Chinatown as our subject matter.
Thank you, Jiying. So after researching different elements of Pittsburgh's history, we were surprised to discover information on a Chinatown that once existed in downtown in the early part of the last century. And we were instantly taken by its story of a close-knit community. And after conducting more research and speaking to Shirley Yi, we decided our experience would be about guests becoming Chinese immigrants living in Pittsburgh's Chinatown, with the target audience being foreigners, international students, and anyone interested in multiculturalism. So here is a demo of what we have so far. So as you can see here, this initial UI is providing context to the guests on their role and objective. And they are in a room, and what Arena can do is interesting use of presence by giving guests avatars based on the world position of their device. So here they discover they need to acquire building materials, and they purchase them, which then also triggers feedback in the physical space. This will be controlled by an IoT architecture. They apply it to the city, and then, this is from another perspective, someone realizes that they don't have the resources to purchase something. So they can work together to give money to each other in order to purchase said materials. And then once they have the resources they need, they can apply materials to Chinatown to change its state. So here again shows feedback in the physical space. They apply it to the scene, and they are rewarded by seeing Chinatown in its completed state, architecturally. So Chinatown's story of a strong community really appealed to us because we could really utilize Arena's strength of creating collaborative mixed reality. So the guests complete collaborative interactions that teach them about the lives that the Chinatown residents led. And this experience we envision taking place over three key time periods in its history: 1890, 1930, and the present day. And we have chosen these periods because they are key in that history, in the 1890s, that was when many of the first immigrants were coming and settling. In the 1930s, it was Depression era in America, but it's also the time when the community really worked together to support and look after each other. And then we go to the present day, where guests reflect on the impact that this Chinatown had on Pittsburgh's development. We are also going to be, seeing as we're in room 3306, we're going to be using LBE elements. And what we want to do is, because there are no windows in that room, we can control light. And that's where IoT elements will be present. And I think light lends itself well to the whole idea of bringing light to a subject not many people know about. So on the left, we have the conceptual design with the right of the room as it looks right now. And it'll be filled with stations where guests go to complete interactions at different points. So here are two examples. On the left, we have the station for when guests go to get building materials. They would go towards this station, scan the April tag in the center, and once they get close, embedded sensors in that structure would illuminate pictures from Chinatown at the time. On the right as well, in the 1930s timeline, when they are looking after guests by cooking, they would go over, scan the April tag, and food would appear in 3 of the different bowls with light serving as feedback as well. Before we started, we paper prototyped different kinds of collaborative interactions to see how we could design this to share information amongst guests that encourage collaboration. And that, of course, is one thing we learned is very important, is making sure that everyone is aware of a common goal. And they all have bits of information that there's distributed amongst each other that only they know. So they have to work together to find out what each other knows to achieve that task. And as I said, in the 1890s, they worked together to first acquire materials to build Chinatown and make it their own. In this case, they are sharing money as new immigrants to Pittsburgh to buy resources, which they then apply to Chinatown to change it. And we want guests to feel a sense of intrigue at first with pride at the end as they see the results of their collaboration. In 1930, they are working in Kwong-Yitong, which was the central hub and heart of Chinatown as the general store. And in this, they are preparing meals for residents of Chinatown. And they, at the end, seeing again as this was Depression era, an interesting bit of information we found out was the white community would often come to Chinatown to buy fireworks. So at the end of this scene, there would be fireworks in the virtual space, again, enabling guests to feel pride and their collaboration in this scene. And lastly, all guests tap on Chinatown Inn and they see the plaque, which is currently erected in downtown, commemorating Chinatown's history. And this, we would like them to feel a sense of hope and reflection as they think about the impact of this community on Pittsburgh. Now, Penghua will walk you through the UI.
Thank you, Anton. So basically, our project is a AR project, also combined with location-based entertainment. Therefore, we designed a mobile UI for Arena platform. So when you're using your phone to open our project, first you get your name card of this role. You'll be assigned to a specific role, and you know your background, why you're here. And after that, we have 3 main sections on the mobile phone UI. So the first section is going to be the narrative section, that users could read their whole background and the storytelling parts and why they're here. And second section is going to be the interaction between users and NPCs. Whenever users are walking next to the NPCs, those tasks will be triggered, so users could tap on their phone and see like what task they're gonna get. And the last section is users' interaction parts. So basically on Arena platform, they could see other users are floating around in the air, and then like they could tap the other users to send them important messages or transfer money for this game. So here are just some examples of those parts. And also we did a play tests based on this UI prototype, and we have several takeaways. First, we conduct this playtest on main campus, and one of the limitations we have when we're doing the playtest on main campus is, since we're a location-based entertainment experience, it's hard to make users feel like they are actually inside a room to do this project. So after playtest, we got some advice, and the first one is the users want to see more combination between our mobile experience and the actually location-based experience. And we're gonna conduct playtests in the room in the future. And second is the users, they want to see more detailed narrative about each roles inside these games. And we're gonna develop several details after the halves.
As research is really important for our project, we have conducted several research. We first watched Lena's documentary film about the last mayor of Chinatown, and we have interviewed Shirley, who is the daughter of the last mayor of Chinatown. We also went to the Pittsburgh Chinatown Inn, which is the last remaining building of it, and we have been to the Heinz History Center Museum to see more materials from that time. And based on the research, we have made our concept art as historically accurate as possible. And you can see here's how our concept art of the architecture changes from when there's no Chinese immigrant and Chinese architectures pop out. And for current day, you can see only the Chinatown Inn is remaining. And we also made
illustrations to see how the first Chinese immigrant arrived at Pittsburgh and made brand new UI of the Pittsburgh Chinatown.
So our 3D modeling is based on the traditional Chinese architecture. Also, we did lots of other Chinese building, and we also referenced the Pittsburgh Chinese Chinatown, and we made lots of character to match the topic.
All right. As we dive into our project, our first step is to master the Arena API with a focus on Python. Along the way, we learned that Arena is good for its cross-platform accessibility and the ability to have multiple people collaborating in the same virtual space. However, we've also noticed that performance can vary on mobile devices. And while the platform is overall powerful, we sometimes bump into the edges of its current feature set. So a crucial part of our work is to collaborate with Arena's team to tailor solutions to enhance our experience. With the unwavering support from Arena's team, we put much effort into the infrastructure of our experience, including screen space UI, avatar system, scene management, and NPC logic. We've also found easy ways to integrate our assets and incorporate location-based entertainment elements into our experience. All of these efforts are invaluable, not just to us, but also for Arena team, and as we provide feedback and work together to enhance the platform for future development.
And in terms of timeline, as we showed in the demo, we have already finished the first stage of our project, and we will be working on for the second stage and also the ending of our project. And I believe with our design and also our tech infrastructure we have built, we were able to finish that before the soft openings, and we'll be finalize it during the final. And we'll be delivering a final demo for our client and also everyone else. And thank you so much for coming, and thank you so much for listening to our project. And we're now open for questions, concerns, and comments.
Are you purely focusing on kind of the LBE paradigm, or can I do this with a friend at different locations?
So Arena's platform is supporting both VR experience and AR experience. So although we've added some LBE taste into our prototype and hopefully in the final product, we also want to make it compatible to virtual VR experience so that people can enjoy it in their home, on their laptop even, and can open their video and audio feed and enjoy it with their friends. Yeah.
Questions? All right. Thank you.
Thank you.
Hi, hello, we're Team Federer Friends, and welcome to our Halves presentation. And this is our project Animal POV, a climate challenge. So this is our team photo, and let me introduce our team members. This is Howard, our programmer slash VFX artist, and this is Jojo, our environmental artist. I'm the producer of this project, and this is Lisa, our 3D like animator generalist. And this is Ming Hao, our riggers, tech art. And Kimi is our character artist. And here are instructors and clients. John Dessler is our instructor, and we have Laurie and Diane as our clients. So project in a nutshell. Animal POV is a climate challenge. It's a single-player VR game that enables people to perceive the world through the bald eagle's eyes. In this game, the player will experience the climate change challenge that affects the bald eagle's eyes and find out the solution at the end of the game. So we design our game for people from 15 years old to 50 years old, and we want to make our game accessible for people who really care about the climate change. So here are our project goals. The first one is that we want to incorporate the storytelling into our game experience, and second one is that we want to let the players resonate with the climate change issues. And the last one is that we want to deliver a very immersive bald eagle simulation experience to the players. So our game has 3 stages. The first one is before climate change, and the second is after climate change, and ending with the hopeful note. So here is our very abstract storyboard. So guests basically start as the young eagle in the first stage, and it will following the instruction and flying with mom eagle and to learn how to catch fish. And then they will flying towards the big tree and with the mom. And at the ending of the first stage, there is a 20 seconds video showing how beautiful the environment used to be and how time goes by. And at the stage 2 and 3, so basically it's 20 years later, guests start in the nest again, seeing wildfire. And they try to escape from the fire, and when they pass by, they will say anything. The environment has been changing, the lake has shrank, and they will flying towards the river to find a hopeful habitat. And there is a 30 seconds video at the end showing how climate change affects the eagles. And here is our demo.
Young bald eagles hatch from early April till mid-May, and they will remain in the nest for 10 weeks until their first fledge. Now, it's your turn. Look, your mom is waiting in front of you for your first flight. You can keep flapping your wing to take off.
Look at where your mom is heading. Don't get lost. If you want to speed up, flap your wings again. Use your eagle eyes to target the fish, and pull the trigger to dive. Your goal is to catch 2 fish today.
So the caption in the demo is just for demo. So in the game there is no subtitles.
This is our pre-production to help you to know how we iterated from our beginning stage. And I'm gonna talk about some of the basic mechanics for our prototyping. So the first one is the flying mechanic. A player are able to fly, to take off through flapping their arms, and they are able to speed up after they are flying. And as you can see, there is a mom eagle. Mom eagle is gonna guide you and help you to the destination, and you are able to follow your mom. And once you are get lost or get too away from mom, you will be respond near your mom and to help you in the right path. And the third main mechanic is as you are an eagle, so you are able to catch the fish. So the left image is for the prototyping. You are able to like selecting object using your eagle eyes, and yeah, like your the object you are looking at will be highlighted, and like in the right image, once you select the fish, you are able to like dive and catch the fish. And yeah.
So for the playtest and feedback, we attended the Tuesday playtest night, and this is the result we got. So altogether, we had 7 playtesters, and 3 of them, they said that there's some bug. They couldn't have the catching fish game. And 5 of them, they said that the flying speed is too slow, and it took them too long to get to the final destination. And 4 of them said that they took too much effort to take off. So based on the feedback, we had some design iteration. So for the first iteration, we changed the flying mechanics to have like the speeding up function. So you can see like in the second animated picture, we have the speeding up when the player flapping their like wings. And we also changed from the long takeoff time to the easier takeoff. So we also have the energy bar in the second picture, like to show the player how much effort they need to take to take off successfully. And so the left picture is our first prototype in speed up visual effects, which is kind of confusing based on the feedback. So we changed it to the second one to make it more clear. And some of the players, they don't exactly know how to fly like correctly. So we add the instruction page at the beginning of the game to show that how they could try to fly by swinging the controller.
I'm going to talk about the art. So for this project, we implement 2 procedural generation methods. One is we created multiple types of trees using speed tree, and also many rocks using Houdini. These methods greatly shorten our developing time. And this is our hero asset, the bald eagle made by Kimi. The model is already finished. You can see the topology is clean, and it's ready for rigging and animating. This is how it looks with the material on. The texture is still a work in progress. And these are some of our reference images. We decided to choose the stylized art, considering the performance of Quest 3 and also the preference of our target audiences. These are 2 terrain we designed during the early stage. One is a more common looked one, and another is a more pixelized one. After discussion and testing, we decided to use the first one, the normal looked one, considering it will be easier for us to make the rest of the assets, and also it's more intuitive to address the climate change issue. These are some screenshots of our current environment. You can see the close-up of the trees and the rivers, and also from the perspective of the eagle. This is the fish we made with the animation. It will be in the water for the player to catch. And this is the fire in the second stage.
Okay, so I'm going to talk about the remaining tasks we are going to finish for the next step. So first, for art and UI perspective, we are going to finalize our eagle rigging and animations. The eagle rigging is already in progress, going to be worked by Winghao, and it's have a good start. So we're going to prioritize this task as first. And secondly, we're going to continue polishing our environment art. We're going to adjust the terrain. We're going to populate the environment with trees and rocks to make it fulfilled. Also, we're going to improve our user experience by joining the playtesting night. We are going to invite more guests to playtest our game, and we are going to collect better user feedback for them. Also, for the gameplay part, we're going to complete the second and third stage. So the second stage is the one with the forest fire. We're going to complete that stage with better game mechanics implemented. Also, for the third stage is just a happy ending. We're going to make sure we talk to the client and play testing to make sure it has a smooth transition. So the last part, we're going to create a cinematic transition between the first and second level. So that's going to create in Unity. We're going to make a render based on the art assets we already created. Okay, next is our detailed timeline for the next step. So after the today's half presentation is the spring break. Minghao is going to finish the rigging for the Eagle. And after we came back from spring break and the week is before the GDC, so we're going to put our remaining tasks like in this week. The first one is we're going to start the animations for the Eagle. We're going to make sure the mom eagle's flying path works well. Also, we're going to populate the environment art with the other assets we already created. It's also a good chance to the playtesting because on week 9, we're going to join the Tuesday playtesting night to let more guests play our game. And we can make the changes before the final. And after that is the GDC week. So 3 of our team members are going to GDC, including our programmers. So that will be a art focus week. We're going to make sure the environment art is finalized and polished before the next week. After we came back, we're going to make sure the cinematic transitions work well in Unity. We're going to make the render with the AI-generated voiceover, and we're going to complete the ending of our scene with, by talking with client. Yeah, we are kind of put our schedule forward to make sure everything is finalized and polished before the final. So in conclusion, our game is a 3-stage Eagle simulator, and it enables players to experience climate change issues through the eyes of both eagles. So our team members, we are all animal lovers, and that's why we form our group as feathery friends. And our ultimate goal is to use the bald eagle as a symbol, but it represents like other animals who may be endangered and are affected by climate change. So we are going to make a contrast between before and after the animal's habitat and life of the climate change. We are going to illustrate how we as humans could help them to deal with problems arising from climate change. Yeah, and that's really all for our presentation. We are open for questions. Thank you.
So one of the effects of climate change I think you're doing is that it's going to get hot, there aren't going to be as much fish, you can't eat as much. I'm not sure if your eagle lives in big trees and if you're also showing that it's just hard to find big trees to set a nest in. Is that another piece you're going to try to communicate, or might that just be in some of the video you're going to have later?
So yeah, I think it's in the second stage, there will be less tree for eagles to build the nest. So that's kind of our plan. So.
And will that change the art of the trees, that these are trees that can support nests that weigh 2,000 pounds?
Yeah, there will be less big trees. So in our scene, at the second stage. So.
Yes, so first stage, we will see those big, big trees. Okay.
You've got this other eagle as a major visual focus, and it feels like you're putting a lot of emphasis on that as a character, but it's not animated yet, and it feels like the animation and how that character comes to life is a big factor in how this will look and feel, and I'm just kind of curious how you are planning to like make that work and iterate it.
Definitely, I will finish it as early as possible and ask for many instructions instructor's idea on it. Yeah, try my best to make it believable.
Other questions? All right, thank you, team.
要放映，对，右下角，OK，不，要放映上，右下角，Yep, that's.
Hello everyone, we are Team Crusher. We are making a game about sign language. Here are team members. I'm Chloe, and this is Karen, Tyler, Bella, William, and James. We have an incredible client, JP, from psychology department, our amazing advisors, Tom and Heather. Our mission is to create an engaging game for sign language learning. And we have a live demo to show our progress so far.
So this is the minigame 1 we currently have. This is the letter selection page. Player can randomly generate the letters, or they can choose which letter they want to learn themselves. After finished choosing the letter, they can press start to enter the game. So this is the minigame 1 page. Here's the skeleton. And in the middle is the letter they're gonna make the gesture with, and that side is the hint image. They need to follow the hint image to pop the balloon and feed the cat. On the top is a progress bar that the player needs to fill up finish 20 letters to finish this level. And yeah, if anyone are interested, you can come to our project room to try it.
So our project goal is to make a game that teaches hearing people about American Sign Language alphabets. We've also set 2 stretch goals. First, to expand the alphabets by introducing some simple words and phrases. Second, to support data collection, making the game an extensible research tool for our client to study ASO learning patterns in future. We have 4 deliverables: sign language tracker that recognizes signs and gestures, a functional game, an expandable vocabulary database, and research data collection APIs as a bonus. Delving into the components of American Sign Language, it's not just about hands. Facial expressions and body movements also play an important role. But our project focuses on hand gestures for letter forms and spelling because they are fundamental to ASO learning, and we will include facial and body parts for our stretch goal. After reaching out to subject matter experts and conducting online research, we found the importance of visual spatial skills, memory, and engagement in ASO learning. So when designing our game, we incorporate visual stimuli and feedback to enhance visual learning. We encourage consistent practice to strengthen memory retention, and we use engaging narration to enhance gameplay and increase player engagement. Next, I'll hand it off to Bella for more details in game design.
So the key design principle for our project is simplicity. This allows us to strengthen the direct link to sign language learning from our game, and it also allows for better data collection for key metrics such as accuracy and reaction time. We have a total of 3 mini games in our projects, each targeting a different aspect of sign language learning, namely accuracy, reaction time, and memorization. Our first game serves as our tutorial level, which we just demoed prior. This is a low-paced, low-pressure game environment. In this game, the player gestures correct letter to pop the balloon, which will feed the cat a little fish treat. This level really encouraged the player to accurately memorize the sign language for all 26 alphabets. In our next game, this serves as our speed level. In this level, the cat is speeding through a miniature city set sitting in our living room, and you must obliterate the obstacle in front of the cat to keep her going. This required the player to gesture correctly in a limited amount of time. It requires fast reaction and encourage player to reinforce their memory repeatedly. For future research purposes, we will also collect letter reaction time data from this level. We currently have a working, functioning gameplay prototype, and we're working on the environment art. For our third game, we really want the player to apply the alphabets they've learned to communicate words. In this level, you gesture the correct letters to spell the word on the screen, which will earn a little cat-like stamp from the cat paw. We're using primarily 2D art asset to lessen the pressure on art aspect to include more vocabulary. This level also required the player to be familiar with all 26 alphabets. And similarly, we're gonna collect word reaction time from this level. We also have a functioning gameplay prototype for this level right now, and we'll have more updates very soon. And I'll hand it over for Tyler for more tech breakdown.
So we're making a game about hand gestures. So the big question for the tech part is how can we get the computer recognized and also communicate these gestures back to the user? To achieve this, we start with computer vision. We use a webcam and also a software library called OpenCV to allow the computer to receive information from the real world. Then we use tools provided by Google Media Pipe to identify human hands in real time. And here's what it looks like using OpenCV and Media Pipe for hand detection. The reason that we use OpenCV and Media Pipe is that to focus on a balance between being lightweight and also accurate for our game. Once the computer can see hands, the next step is to teach the computer to recognize specific hand signs. We can accomplish this through machine learning. Machine learning is a way we teach computers or machines to learn by letting computers look at patterns or examples of things. The intuitive approach is to teach computers by showing images of hand signs. However, instead of showing pictures of hand signs, we fed data from the 21 landmarks provided by MediaPipe to our machine learning model, which is less data required, and it will shorten the data collection process, also the training process. We trained a neural network model with around 1,000 landmarks data for each sign, and our current model accuracy is around 98%. This is a demo that shows the model outputting the signs I made and also the confidence score. The main challenge we faced during the process is to distinguish similar signs like M and N. We overcame this by feeding more data with different hand size, different hand shapes, to let the computer to find out what are the key differences between them. We also tuned some variables called hyperparameters. Hyperparameters are variables that controls how the model is trained. Just like teaching people, we need to teach computers with the right amount of rounds, the right amount of examples each round, and a right amount of a lot of things. Finally, after some tuning, we were able to result the model we have now and finally put it into a game.
Okay, more tech. So our sign language tracker is written in Python because Python has better integration with MediaPipe and TensorFlow. But since our game is in Unity, how Unity game and our sign language checker work together was a challenge. Also, normally if you want to run a Python script, you need to install Python on your machine, but we don't want to add more works to the user. So here's our solution. We build the sign language checker to an exe executable file so that with all the required libraries embedded. When our Unity game starts, it will automatically open our tracker. And while the tracker is running, it will identify the hand and broadcast the landmarks, the sign, and the confidence score. It's like, hey, I think I got a pulse. I'm 90% sure it's an A. Well, at the Unity side, it will just listen for that message. And we don't want our game to be limited by the 26 letters, so we provide the ability to let our client add more words into the game. And the recipe here is use the Unity asset bundle. Basically, letters, image, and models will be stored as a bundle, and the game will access those bundles through a JSON file. So instead of changing our game source code, the user can just change the JSON file to add more words. Quarter feedback. So we receive a lot of feedback during the quarter. It's mainly on the art design and the art part. Thanks to Taylor's great work, there's not much about the code. So we have learned that as an educational application, our game needs to have a learning ramp, basically to teach the players through a process. Meanwhile, as a game, our project needs to have an interest curve, basically make the teaching fun. Finally, our game needs to make sure that players know how to do hand tracking before they actually get into the game. So with that, we now update the game flow. Now the player can choose which minigame they want to play, as well as the difficulty level before they actually enter the game. Also, there are 3 ready scene. They are the check scene, just make sure the hand tracking works. Our 3 minigames has 3 different art assets, game mechanism, and purpose, so that the player won't feel bored while playing the game. Also, like Bela mentioned before, our first game is basically focused on tutorial. The second is more like practicing. The third is using what you have learned to do some creative work. So it kind of creates this learning curve to kind of teach the player step by step. Next, Karen will talk about the art.
So for art, our main feedback is keep it consistent and simple. So we choose a low poly style. And since we have 3 distinct minigames, each serve a different purpose, we decide to introduce a character to keep the whole theme coherent. So after rounds of brainstorm, we decide to use this head-on robot as our main character to lead the player throughout the entire learning journey. Yeah, and also this character has a Yeah, this character is easy to use because we don't need to animate the walking cycle. This is our environment model for level 1. And after import the model into the scene, we did optimize the camera lens and remove some meshes and also add materials to minimize the distraction while keep the visual appealing. We also add dark skybox and change the light to keep the background dim so we can make the foreground stood out. Next, I'll hand it over to William for iterations.
Thank you, Kellen. So for iterations, this is the very initial prototype that we had. You can probably see it, the structure-wise, it looks similar with the demo that we showed you guys earlier, but there's a lot of function that's missing and the features that's unresolved. And we brought this prototype to the playtest night at Han Library, and we found some really valuable feedback, such as players getting those random hits. So whatever they're doing with their hands, whenever we detect a right gesture for the letter, they'll instantaneously pop. So that's not good, and they get frustrated. So in order to fix that, we introduced a time buffer function, so the player has to hold the correct gesture for a little bit of time in order to pop the balloon. And they also found it to be too intense for the tutorial, so we totally removed the whole score system and the timer so they won't be as pushed. And for the UI part, we agreed on to make it really simple and clear, and also add some prompts when necessary to guide the players through. So this is our next iterations. You can see the time buffer is already implemented on the corner. And also the progress bar is really minimal. Now it only shows the player that how many more letters he has to go through. And then the left is the image that the player can reference on. And then we thought about, why don't we just make the time buffer, the letter itself, because the letter is the focal point, and we want the player to look at the letters, not like the other UI elements in the scene. So we developed this shader to help the players know their progress and also gradually fill up and pop, which make more sense. And this is our UI. You can see it's really friendly, really clean, really minimal. So we reduce the amount of destruction when players are like navigating through these. And the last, this is our current iterations, the same with the demo that we got to show you guys earlier. And last but not least, Koi will introduce the next steps.
So our next step for the tech part is to integrate motion detection model so that we can detect the letter J and Z as well, and we'll keep developing the 2 other mini games. From week 8, we'll spend 3 weeks completing all the gameplay and then do more play testing and iteration from week 11. And finally, we'll work on our documentation and stretch goals. Now we are open for questions. Thank you.
Really nice job. Can you, 2 questions. Can you imagine a mobile device version? And then part 2 is, a project like this, you get really intimate with the information. Have you guys learned sign language?
I think for the first question, I think mobile version is definitely possible, but we are, at least for this semester, we'll focus on the desktop.
MediaPipe works on mobile, so it's doable. Yeah.
What's your client, what's the expectation? How do they want to use this?
Our client wants to use it as a research tool in future, but currently for this master scope, we'll just make a engaging game for players to play the game and learn sign language.
What was the demographic again? I don't remember if you mentioned that.
Like he doesn't give us a like specific range of ages, so basically everyone who wants to learn sign language.
And like to add a little bit more on that, our client is using this for like future psychology research that he's doing. So he wants this game to be as accessible as possible for like all range of people, especially like hearing people, to access this, so that he can in the future like collect data and like write a paper like on this. So this is like basically like a tool we're developing for him to use in the future.
Jonathan's the first.
I have a few questions, short questions about your interface to make sure I understand it. The first one is, why are the hand gestures mirrored relative to the sign hints? The second one is, can you flip a setting to get rid of the sign hints so that they can memorize the gestures more easily? And then the last one is, have you tested it with really small hands, like children?
Right, so for the orientation part, for the future, we're gonna develop like a setting, or like when you enter the game, it will ask for your dominant hand, and like whichever hand you choose will have like a corresponding image that like match your dominant hand. We're gonna develop that like later in the semester. And then for smaller hands, we've tested on like middle school students when we had like the play testing Friday. They're like not super small hands, but like they're like 11 to 13 like kind of age group, and there's like work fine.
If you want a 5-year-old, let me know.
Sounds good.
So I'll follow up with that, because my question is about April 6th. I'd like to give you all different ages, all different races, and maybe before then, if you can kind of give me any limit, like no younger than 6, and make sure that it works with different races too, because it'd be nice for this to work.
So you're working with a client who's going to use this for data gathering. I'm kind of curious, have you tested the data handoff? So like, has the client actually taken data and used it, or at least do you have plans to like work with the client to actually test the data itself?
Right, so for the game itself, we're gonna implement like a API for, not like an API, like an output source, like in the future, like for game 2, for example, after you play it, we'll output like a document that like document all the reaction time for each letter, so that our client can just use that easily. he also mentioned that on his side, he can do that too if needed. Like he would just have like an actual human to like record the reaction time from the player. So yeah, it is part of the plan for our future iteration, but yeah.
Yeah, I think there's one thing about the reaction time is normally when you learn that second time, it will be faster than the first time. So during our playtest, many students will have to wait for the hint image and mimic it for the first time. But for the second time, some of them just directly show the gesture without using the hint image. So it's sort of a proof of the reaction time.
Is this one more?
What's up with it?
I don't know. Oh. I'm sorry. Oh, okay.
Why would you need? What's happening?
That's good. I'm trying to increase the volume. Okay.
So I want you to imagine for a moment, you are in an art studio. It's blank with white walls and ceiling, scribbled out paintings and unfinished paintings lie on the floor, propped up on the walls. In front of you is an art desk with a couple of paints. Some of them are cracked open. There's a blank canvas in front of you, and next to it, a paintbrush. Curious, you pick up the paintbrush, and you begin to paint. You see your mother. You're much younger here. She's teaching you how to paint. There's some things missing in this scene, hard to remember, but you don't care. It's warm with her and safe, and you try to ignore it. You paint again, and again a memory reveals itself. But this time the memory is angry, uncomfortable. You don't want to be here anymore. There's some things in your memories that don't belong there. This is team recollection.
This is our team. Our project advisors are Brenda and Chris. Recollection is a VR narrative experience about how people with trauma process memory and their perception of self. Our goal is to encourage empathy in people who don't have experience with these symptoms. And we've been testing our experience repeatedly with our subject matter expert, Dr. Sarah Butterworth, who's associated with the Pittsburgh VA. The experience is fundamentally that you begin with the cinematic opening, giving you some context about the story, and then you proceed to paint objects in the scene, which reveal new memories in the room scale VR space, and fragments within those memories. Within them are other paint colors and objects that you proceed to paint until you unlock everything in all of the memories.
So our core gameplay loop in this demo is that you start in the art studio with covered up paintings. Upon painting these covered up paintings, you reveal memories and new scenes that unfold before you, but they start out blotchy and ill-defined, and you have to paint the environment to reveal the underlying detail and reveal the aspects of the narrative and this character and their experience of trauma. As you do this, parts of the environment will bleed into each other and change as memories fold in and start to change the environment, and you get access to more and more things about this character. And you continue this loop, getting more and more memories intruding in and learning more about this character as you paint more and more in the environment and more of these scenes.
So because we pitched this project last November, we already had a sense of what this project was going to look like, we had a lot of ideas. So we started early in the semester, we brown boxed these ideas, we tried to feel what the interactions would feel like, and we got a good sense of what the project was going to be. We found some blind spots. So then we took advantage of the playtest nights at Hunt Library, and we took it out of ETC. We translated our ideas into a storyboard, and we wanted to test with people outside of ETC to see if the visuals, or the colors, and the narrative that we chose was having the emotional impact that we wanted it to have. While we got some great data, the most important thing we got from the playtest were the potential challenges we will face, and we are facing during production.
So I'm going to talk about the game design challenges that we faced through this process, the primary one being engineering a narrative and gameplay at the same time for our purpose. As neither of them precede the other, we are not really adapting an existing story into a gameplay, nor are we creating a plausible story to wrap around a mechanic. It's been helpful to pivot our goals around emotions, and we've been iterating back and forth from narrative and game to see what serves our purpose better for our transformational emotional goals. In the same vein was the challenge of balancing the pillars that for our project. The first one being transformation. We wanted to ensure that the experience we are relaying is as authentic and as sincere as the seriousness of the subject matter demands. We also are exploring new avenues in how to convey emotion and story to the player, which is our novelty pillar, and the requirement of engagement to create any sort of impact. The last challenge that I'm going to talk about is storytelling in room scale VR. While this medium is really helpful in putting someone directly in the character's shoes, it's challenging to control where the player is going to look, what they're going to interact with. So we are using visual storytelling and auditory cues to direct the player's attention and see what they would get information from through environmental storytelling. While the VR can allow you to be in any part of the world through just a headset, it's also a challenge to navigate the spatial restraints and mobility of the players. So that we are using vignettes and other tricks to try and control the player experience.
So let's talk about Sam, our player character. Early on, we had a certain story we wanted to tell. Sam is a painter who has undergone a car crash that killed their mom in front of them. And that is the trauma that they have to deal with after the crash. But we ended up taking a more ambiguous or universal approach to the character. Otherwise, Sam was meant to be relatable to anybody, and a player could potentially project themselves into Sam's shoes to easier empathize with them and to better facilitate our goal of empathy towards people with trauma. But this approach caused problems. One was problems for the team. When your character doesn't really have a background or gender or any defined information about them, it's very hard to write for them, write scenes, or figure out what the environment is going to look like. We don't have any context to go off of. And the second problem was more about the core pillars of our project. This is early on through our research, we understood that trauma isn't universal for everyone, right? different people undergo in different ways and experience in different ways. So then why are we making a character that's supposed to be a universal representation of trauma when that isn't the case in real life? And so we decided to take a new approach where instead of having a character with no defined gender or background or having very generic relationships with the other characters in the story, Sam is now pretty defined. They are a second-generation Indian American person, they are non-binary, and they have complicated, if loving, relationships with their family members. And I want to emphasize that this is not information that we're just throwing at the player and explaining to them. This is more information for us to go off of when we're creating environments to kind of depict aspects that aren't necessarily like 100% defined. We're still staying in that ambiguous emotional space.
So one of the big challenges that we have been facing and dealing with is the ways to visualize and mechanize interacting with memory. Memory is a complicated subject. I mean, it's the way you remember things, the selectivity of memory, the way that you make connections between memory and they bleed together, and the things that you misremember are all complex and vary from person to person and are not exactly easily transferable into a visual and gameplay space. And this is complicated even more with the introduction of trauma that can add things like pushing away memories or being defensive about them and not wanting to interact with them. So we had to develop techniques to visualize and mechanize this. The first one was, of course, conveying the difficulty of remembering through the painting of the environment. This character's an artist, so the way they interact with the environment is to paint, and it shows their process of remembering things slowly and having to work through it. And we also use it as a way to convey difficulty by having objects not be accessible early on or have difficulty in being painted. The other was showing the connections between memories by having the scene being able to bleed into each other or have other scenes intrude on them. And the last one was just conveying the emotions tied to memories and also their ambiguity by using the watercolor style and the amorphous moving nature of the environment to convey the emotion of memories and our weird relationship with them.
So in terms of next steps, for our 3D art, currently we have all of our environments blocked out and our high priority assets are close to being finished, as you can see with the car there. And we have developed a texture style that works alongside the shaders created by our programmers, and we'll be starting on texturing the entire space next week. And in terms of visual tone, since our game is really emotionally heavy, we wanted to kind of tone certain memories with colors in order to represent the emotions that we want to evoke. So for example, with happier memories, they're represented with yellow, while black represents intrusive and confrontational memories.
One of the things we would like to solicit feedback on is how to best depict the car crash scene in the game, both from a technical perspective in terms of what we have the time to make and what will be most effective for the audience. Given that our game is about how we perceive memory, we're open to perhaps you only remember portions of the crash, things before and after, fading in and out. We could try to simulate the crash in-engine or a cache simulation or play with abstract displacements of the geometry to represent it. And like I said, we're interested in anyone's feedback.
Our final goal for this project is to submit it to Serious Game Conferences. Our audience are people at the Serious Game Conference that enjoy and would like to learn more about trauma. We have realized that the submission date for us would be after this semester. So while we have identified some of the conferences that we'd like to apply to, we are open to suggestions. So if you know of conferences and events that this type of game where we could submit this, so please reach out to me. And that's it. Thank you.
Your storyboards are so rich and powerful, and what you can do with painting just in 2D is also very strong, that if you wanted to, you could pursue looking at how does this work in VR as you plan versus how does this work just straight up in 2D delivered in a browser. And what are the differences? I'd actually be very interested to see if you'd find something like that. It's above and beyond, but if you want to pursue a research paper, you could probably do something with that.
I will note the storyboards are we put into a Twine demo which is what we were playtesting at Hunt Library. So we have been doing a little bit of that comparison, but it's largely been about like the distinction of whether or not people understand the scenes, which we're only now getting into them interacting with the space.
Also, with a medium like Twine, we discovered that because there's only a limit of choices that you can offer to a player, they see it more as a game than the seriousness of the theme that we want to create. So it's kind of distracting from the empathy goal that we wanted to achieve. But it would be interesting if we created a 2D environment, so we will make a note of that. Yeah.
Don't you think when they put on a headset, they're going to say this is a game?
It's because you are actually interacting with things. We don't have choices that are wrong per se, because your interactions are leading to different scenes more so. So I think games have more risk-reward of a metric to them that's not translated to our experience.
To add on to that, when you put a VR headset, you're not just seeing text and images and then concrete choices that you can take, like choice A and choice B, which might emphasize the fact that, oh, maybe there's a right or wrong choice, or like, how do I get all the story? In VR, you're experiencing the environment, the art, the music, and so a person is kind of more immersed in that experience than they would be playing a Twine demo.
I'm curious how working with an external expert has changed the project. Like, what feedback have you gotten from them that has changed what you're doing in your design?
I think the conversations we had with Dr. Butterworth kind of emphasized certain aspects of trauma that she sees all the time in her patients. And so it kind of helped us focus more on narrowing down our transformational topic and seeing like which aspects of trauma do we want to depict, because it has many facets to it.
And to add to what V said, we got anonymized testimonials from Dr. Butterworth and their colleagues, so our narrative is inspired and essentially grounded on those testimonials. And we're also sending our storyboard iterations to Dr. Butterworth to sensitivity check our material.
I have a quick question. How are you researching this particular type of trauma, and then how do you abstract that up to other types of trauma, and what have you found to be those connection points?
So like Danny mentioned before, a lot of it comes from first-person testimonials, or I guess some of it comes from first-person testimonials that we found ourselves, and some comes from Dr. Sutter Butterworth, who has given us several different stories of people experiencing car crashes, how they remember them in the moment versus how they react to them afterwards. We also have done research through articles on art therapy and through books like The Body Keeps the Score, which is kind of a more universal or like a broader take on what trauma might look like in people.
Also, when we pitched the project, it was based off this article which emphasized on how trauma can deconstruct your self-narrative and add punctures in it, which might be hard to look back on and visualize yourself as a whole. So it started from that, and we've been adding to it as we go. We've been also in touch with people from Center for Transformational Play, which has been helping us directing our focus on how do we balance transformation aspect of the game and ensure that it's engaging.
Oh, and to add on again, since Keisha mentioned it, our design changed a lot from the initial design through the article, partly because the article talked about CPTSD specifically, which is when someone experiences trauma over and over, say, in their childhood. And so, like, that experiences leaves memory experiences a lot more disconnected and hard to decipher, whereas with the testimonials with the car crash, which is a single trauma, like people still could tell when what events happened because this was just one incident and it didn't affect them as much as CPTSD does.
It's time. Thanks, team.
Thank you.
Check, check.
Hi, we're a team Beyond Touch, and this is our team. These are our cool instructors. Gerard is a SME of us. He's a senior manager from Apple. He will be giving us tech mentoring. So let's head on to our video first.
That's just like that. Look at that.
So, yeah, before we start, do you guys have an idea about how many Apple Watches are there on the market right now? So this is the number of Apple Watch sales per year. Quite a few, huh? And how many games are there on Apple Watches? Less than 200. And how many social games are there on Apple Watches? 0. So let's talk about our project. So our goal is to fulfill this empty market by designing a set of social games augmented by Apple Watch's features. So to be more specific, we are facing an empty market and we have like basically no reference. And we are targeting middle school age students to college age students. And we'll create multiplayer games for 4 to 6 players. And we will cover all of that under a cool theming. So how can we evaluate ourselves if our social game is success or not? So we just do these lines. Are we making people talk a lot? And are we making people move around? Before we head into our development stage, we actually need to test out Apple Watch features to see each of them if they have the potential to create a good social game or not. For example, the heart rate. It has a latency of 5 to 10 seconds to actually show your heart rate, but we think it can actually add another layer to people's communication to see whether each other is like, for example, on my wrist, you can see it's super red right now. That means I'm super nervous and super excited right now. That's another layer of communication, right? You can see, or you can tell whether each other is lying or not. And that could be a cool gameplay. So during this stage, we gradually tested out all the functionalities to see whether they are good for making a game or not, and we tag them down with a tag. And based on this, we choose 4 of them to create our minigame plays. And we have bluffing game, chasing game, balancing game, exercise game, which we will discuss next.
Yeah, so let me introduce our first minigame, a bluffing game with the heart rate feature. So we play a lot of bluffing game, and we find that different bluffing game elements like faking your identity, making up a story, hiding information about your decisions actually have quite different effects on your heart rate. And these are the moments that dramatically increase your heart rate in our research. First, when there is a moment of life or death, win or lose, and it totally depends on how good a liar you are. Imagine when everyone stops and looking at you. Sometimes your heart rate just sold you out. And when you have to make up stories real quick, and it has to make sense because you want people to believe it, right? Or it could be the other way around, when you have to exaggerate facts and make it sound ridiculous. And of course, get caught when you suddenly get interrogated. And you have to lie about the lies, and to cover your own ass under such pressure. So in our gameplay, every player is randomly assigned a role, a bullshit teller or a truth teller. And a bullshit teller need to, well, bullshit and make it sound real. And a truth teller need to speak honestly, but somehow make it sound like bullshit. So after that, in each round, the player in turn can question another player and interrogate her. Like, I want to question Hazel, another Hazel, and other player can have follow-up questions to press for more detail. And maybe Hazel panicked and her heart rate just turned red, like me right now. And but remember, Hazel is not necessarily a liar. She might just good at improv. And yeah, and we managed to create an experience that people do talk a lot and laugh a lot.
Going up a lot, babe.
I'm spicy.
My
grandpa jumped after.
As mentioned, we also want to make a game that make people to run and move a lot, so that's why we consider making chasing game with the Apple Watch's feature to detect the environmental audio decibel level. So at first, we did some research on different playground games like Ghost in the Graveyard and etc. And we found out that it's a good idea to actually augment these games by replacing the catch action with the shout action. So here's our storyboard. We'll have one coach player and several agent players, and each agent player will have an Apple Watch to keep track of their current decibel level on the watch. And the coach's responsibility is to chase for every agent players and try to shout to increase their decibel level on the watch. And actually, since there are a limited number of times the coach player can shout, so they have to consider carefully about when to shout. So they can either just like go to shouting in short distance, or they can shout louder. So the agent player will be considered safe if the current decibel level on their watch is less than the threshold, and they will be considered as out if it's higher than the threshold. And if all the agent players are out, this means the coach player wins. So here's a playtest in our video where we show. And compared to other games, our game actually need players to run more since they can shout to increase the decibel level in a short distance. And also, it's need players to take more attention to their Apple Watches since even during running, you can increase your decibel level. And also, it's definitely more throat exercise. And here's our current tech demo. We're able to show the decibel environmental sound like in the Apple Watch and also represented with the UI.
All right. Let's dive into minigame number 3, balancing game. All right, so far we have successfully implemented accelerometer, plus a steps count on Apple Watch. But what's next? How can we make a social game using these two features and make players move around to achieve our social goal? And there it is. After brainstorming, we come up with this idea, a ping pong ball balancing game. And what you basically do is you try to balance your ping pong ball on your bat and avoid it from falling on the ground. And here's a short demo showing how we do it on Apple Watch. Yep, as you can see, the player is moving carefully to avoid the ball falling out of the screen. And then the entire gameplay will look like a relay race that every player needs to move to next player's position. And then for the last player, he or she needs to move to a destination, and the game will be finished. All right, and let's jump to minigame number 4, exercise game. Same question. So we have heart rate function plus a server interface ready. And how can we make a social game out of these? And from the quarters, the most common feedback we got is that we should start from something very simple. And something very simple, we got this. Hot potato. So what does hot potato look like in the context of heart rate? So the gameplay will look like this. The hot potato will always look for players with the lowest change of heart rate in every 15 seconds. So the player with the hot potato in hand will need to do some exercises to increase the heart rate so that the hot potato can be passed to the next player with the lowest delta. If the player fails to do so, then the player will be out. And the winner will be the last player remained in the game. All right, and that's all the mini games we have, and Ivy will introduce the theming.
So a quick recap, here are the 4 mini games we have. And our team wants to fit all 4 mini games in one theme, which actually connect them together, which is just like Mario Party and its mini game sets. And since all the gameplay is based on monitoring our body data, and throughout the gameplay, the watch will keep track on those data all the time, which is part of the game, which reminds about spy movie. Because as a spy agent, you're always monitoring by some kind of high technology will either assist you or can be an obstacle. And you need to tackle unexpected situation based on this kind of monitorization. And here comes our theming. So in our game, you will play as an agent Otter, and your mission is to infiltrate the groundhog family. So at the same time, the invention of smartwatch from the groundhog family can keep track about each member's body data all the time. And if you're unqualified or look suspicious based on those data, you're out. And our game will be a set of training to help you become a better agent. So the first one, the bluffing, here is the situation of true or lie. So most of the time, our heart rate can reveal our true thoughts, but as a good agent, you will need to be clever so your heart rate didn't give away your identity. So it will be a mindful training in which we'll be facing an unexpected situation and respond quickly in a very short time. So here, calm down and try to conceal your watch and also the other people. And the second one is the ball balancing game. The scenario will be handling emergency. So imagine that your Apple Watch is a stretcher, and your mission is to transfer the injury Otter to the safety zone with your team. So first of all, you need to be very careful because any kind of imbalance will cause the injury to fall off the stretcher, which will lead to the mission fail. And second, since it's a relay race, you will need to cooperate and do the teamwork.
So the third one, Agent Phoenix training, is just as the name suggests, is designed as part of the daily training for the agents. It mimics the training mode of HIT, but instead of collaborating, you and your teammate will be competing each other, and everyone will be burned out in like a short time. So this game is really designed to make sure all agents are physically fit and ready for the upcoming missions. And last but not least, as an agent, you have to be quick and quiet all the time during your mission. So this is where the safety retreat comes in. You and your agent friend will be trained by the coach
And you must lower your volume and also keep away from the coach all the time to survive till the last minute. So these are the UI drawings Ivy and I did. As you can see, we use like vivid colors for the interface because we want to make the interface straightforward and simple, so our users can quickly find information they need from a small watch screen. We're also minimizing user interactions because we want the player to focus on one another rather than staring at the watch all the time. So the next step for our teams will be divided into 3 parts: the gameplay, the UI design, and the function demos. So we'll keep refine our gameplay for each mini game, and we'll also develop wireframes and user interface, and also turn those into function demos. And we're also inviting different people to test our mini games during development. And our team will keep working to push these prototypes into basically a polished game map and a set of agent training social games augmented by Apple Watch's features. And that's it for our presentation. We are now open for questions.
You mentioned that like 50 million people buy Apple Watches every year and that you're targeting high school and college students, but do you know if high school and college students are buying Apple Watches?
So the way we figure it out is that between this age, from like 15 to 25, these people are more willing to share their biometrics data to react in a social game. So it would be better our targets.
And also during our playtest with middle school students, actually 12 of them, like 4 out of 4, 12 of them have one Apple Watch, which is purchased by their parents. Yeah.
Well, the game looks very interesting to me. Like, let's say I have a team of 6, but we only have like 2 or 3 Apple Watches. What should I do in this case?
Buy 4?
I mean, well, can we like share it like because we cannot like, let's say I want to do like a.
Actually, you can do this. You can continue our social game without Apple Watches, but the 2 of them with Apple Watches will reveal their like true thoughts by their wrist.
Cool.
So
right, understandable.
You guys did a good job of picking four mini games, and it seems like you learned a lot from those. Was there one that you tried that you sort of threw to the side, but you still learned something from? Just curious about. Yeah, just curious about that. Like, was there an idea that didn't make it into your final 4? But that you thought was still an interesting exploration? Yeah, just basically, how did you filter down to those final 4?
yeah, we actually have a pretty bunch of demos, maybe like 7 or 8 demos, and we play tested them, and we just pick whatever makes people talk or laugh a lot, and whatever people feel excited about. Yeah.
Yeah, it also depends on the technologies available on Apple Watch. So basically, those 4 games are technology driven. Like those functions or features are available and usable on Apple Watch. And then there are many game ideas that we want to try, but we are unable to do so because there's no public API or resources available. Yep. Thank you. Yep.
Why 25? Why don't you push it even further? For a couple of reasons. I think Stephen mentioned about people buying watches. They would have watches later in life. And also couples. I mean, you have 4 to 6 people playing at one time. Couples, that'd be a great game for couples to kind of do things with, between 2 people.
So we are actually not limiting this, but we are like more specific target to this age level because we have a theming to cover all our sets under it, and yeah.
And also not only the aging, I think the more thing we are considering about target audience are people who are interested in socialize and also having an Apple Watch. And the reason is from 15 to 25 is really because it's from middle school students to like college students like us. So that's the why we get this age range. Yeah.
Yeah, and also during our playtest, we invite both middle school students and college students, which we both find it very fun to play these games. And one of the observations that the teacher, so I think around like 30ish or 40ish, I'm not sure, but is very interested in like the bluffing game, and she's like asking if we are gonna publish it on only Apple or like are they gonna work on other watches like other smartwatches. So yeah, I think we have like more target audience. It's just we are now limiting it to this age group, so we can like refine our designs in like a specific direction.
Thank you.
Hello everyone, we are Team Deliberate, and let me just introduce my team first. I'm Yi Chen, and this is Harry, Yuxuan, Aaron, Jimmy, and YC. Our instructor is Charles, and our client is Jonathan. Now let's talk about our project. Our game is about driving carefully in the human's body, and players need to control a microbot vehicle inside a patient's heart. The platform we use is on the PC, and we're gonna use a very cool input system, the steering wheel and the pedals. The advantage of using the steering wheel and the pedals is it can create an immersive experience for players. The goal of our game is first, the control scheme utilizing the steering wheel and the pedals. And second, we encourage players to drive and control deliberately. And also, we want to create an extraordinary environment inside the heart. And we got a lot of useful feedback from coders, such as the prototype as soon as possible, the heart is fun, and find a balance between realistic and the fun. And think about the rewarding and consequence system, and also maybe add more fun features. So based on the feedbacks we got from the coders, we want to make sure create a more interesting experience in a relatively realistic environment. So based on this situation, we will add more fun features such as the white blood cells. The white blood cells will attack the players in some conditions. And also, we will mainly focus on one main level, which is the heart. And also, we will think about the consequence of driving too fast and the rewarding for driving slowly. And next, I will let Aaron to introduce our game design part.
During pre-production phase, we think it's vital to figure out how hardware works in reality. We first got a digital model, but then we realized if it's better, we can use a physical one and hand for reference, and it really gave us a better understanding how the structure and the function works. And we also read a lot of medical articles and even consulted AI for more in-depth information effectively. We watched a lot of films with similar ideas for inspiration. Yeah. Paper prototype. Yeah. We used several card boxes and took advantage of physics to simulate the experience we want to create in the real game. The player will use a string to control a small box, And the goal is to peel off the stickers all around without making the rubber bands and the pens fall down. It worked pretty well, so we could confirm that we were in the right direction. To develop the, what's going on? So sorry. Yeah, this page. It's okay. To develop the idea of driving with care, the first core part is the control. Here, steering wheel for turning, throttle for moving forward, brake for moving backward. We designed the clutch pedal for moving up, so the player needs to press it all the time. Maintain a delicate balance, not too hard, not too soft, to move steady, which encourages careful driving. Also, some other buttons are used for devices of the microboard. The next major part is environment. So we don't want to use only the human body only as just a visual scene for our game. Instead, we want to follow the real structure as much as possible. So we think that heart might be the best organ to support this design decision because the structure of the heart is naturally engaging. We follow the true direction of blood circulation as our level flow, and then we cut the unnecessary routes in order not to confuse the players. And therefore, in the game, the player will start at the superior vena cava, go through 4 heart chambers in sequence, and at last end in aorta. The next part is we need to figure out what kind of elements we can use to support our gameplay. The first is bacteria. The player needs to clear the bacteria, and then white blood cells, because the microboard will be identified as foreign to the human body. White blood cells will attack the player, so the player needs to avoid them. And the third is viruses. The player needs to destroy the viruses to cure the patient. Last but not least, heartbeat. We think this can function as an engaging mechanic which provides a lot of dynamics because the valves of each heart chamber open and close along with the heartbeat, so the player needs to move through them. And the pumping of the blood will actually push the microboard, so the player needs to be extra careful.
So let's move on and have a closer detailed look on the mechanics that we have already implemented into the game. So here is the appearance of our bacteria and spray. You can see the green and yellow bacteria texture on the pink heart chamber. And it is very conspicuous even if you are far from it, so you have a focus to tell you which way to go if you have nothing to do. And on the right is the GIF of how the spray is working on the bacteria. Currently, it looks like you are actually going backwards, and we realize that's a problem, but it's actually the bacteria shrinking and it's going to disappear. So when the player is using the spray, we expect them to hold a button on the steering wheel while their left foot is stepping onto the clutch pedal, which provides an upward force against the gravity to let them stay in the middle of the air. And their right foot should be going back and forth between the forward and backward pedal so that you keep in the same distance from the wall. So in order to make the vehicle stay at the same position inside the game, the player on the outside actually needs to put a lot more effort into that. And it is the kind of chaos we designed for them. So now let's move on to the white blood cell. As we said, your vehicle is going to be recognized as foreign thing to the human body. So if you get too close to the white blood cell, they will target you and start chasing you and cause damage to your vehicle if they bump into you. And we know that they shouldn't just disappear when they hit your vehicle, and we will add some more effects later. And so if you want to get rid of them, you can either choose to distract them, or you can keep enough distance so they will start following you. One thing I would like to mention is how we started from the paper prototype and transited to the level design and game designs. So we took the rubber bands from the paper prototype and turned that into a patient's health bar. And so if you drive too fast, there is a velocity detection system that will trigger when you hit the heart, and it will cause the patient's condition to grow worse. And so it will not look like a visible patient's health bar in the future. We will turn that into an ECG, and it's the vital sign that serves the narration. Given that restriction on velocity, we found out it is very satisfying if you can successfully drive the vehicle through a tiny small hole without causing any damage, and which is the reason we will be leading them to go through the valve you can see on the picture. Also, on level designs, we found out that you can actually ask the player to perform a task while they are being distracted by the surrounding environments. So here we can ask them to drive through some irregular landscapes like the pillars, and then spray the bacteria under the cliff, and then fly away. If they can do that successfully without causing any damage, that is very satisfying, and is the kind of reward we want to provide to the players. So now let's have a look on the demo video of these features.
So this is the demo video of our work from the quarters. And when the player step on the pedals, the nanobot will lift and move forward. And he can then press the button to use the spray to clean the bacteria. And when he accidentally hits the chamber, the patient's health will drop, so he will have to drive really carefully. And now he's heading towards the other bacteria and trying to clean it. And basically now these bacteria will only, when it contacts the spray, it will only shrinks and disappears. So we will actually add more visual effects after the half to make it more attractive. And now you can see there are tiny white blood cells scattered in the chamber. And it will recognize you as outside creatures when you move too close to it. So you will have to choose to dodge or attack it back. It will like chase after you, and it will hit you, and the vehicle health will drop. So basically, this is our demo video, and now it comes to the playtest part. We invited some middle school age students and our ATC students to play our game, and they actually work really well. And they feel that the playtester, and it's actually fortunate that the playtesters are driving really carefully instead of like dashing around in the heart. And they felt like it is actually satisfying to clean the bacteria with the spray. And plus, they thought it was really cool to drive inside a human heart, especially on such a fancy hardware. There are also some points we need to improve on after the half. For example, the camera now is, we need to adjust the camera parameters so that the player can see what is above their head. And moreover, we need to adjust the lighting conditions so that the placing can be more attractive. And we also need to add more animation to the heart to make it more vivid. So basically, we need to adjust these parameters and add some emotional connection for the narrative purpose and add an ending to the game. So now it comes to the art part.
So heart is the biggest art asset in our environment. It functions as the whole environment. So capturing the accurate shape of the heart is very critical to our game design. So I spent a lot of time on studying the anatomy of the heart before I started modeling. And here is the first initial version of the heart, which is a close one that can function both from the interior and the exterior. But later on, we realized that we want to incorporate a heartbeat animation to the entire heart, which means the previous version is not capable anymore. So I recreated the model into this cut open heart, so it's able to be animated and rigged in the interior. And it's also connected to a room that's simulating lawn. And for the vehicle design, the initial version was too old. It has a lot of old mechanical elements in it, and also certain shapes were sharp and not friendly to internal human body. Therefore, I recreated into the second version to make it more smooth, more round, and more friendly. And here is the default user interface the player will see when they enter the game. It has the taskbar and the ESG to represent patient health, and the dialog box, and the crosshair will always be at the middle of the screen. And considering the dim lighting in our environment and also the intricate structure of the heart, we want to incorporate this 3D map for the viewer to toggle and view where they at any time in the game. And here is the design of our instruction to educate our player about our controller. And then YC will talk about our future plan.
Okay, thanks, Yuchen. So there are a few things we want to do moving forward. The first thing is we will have a narration system in a game. So notice that the picture on the right is from an actual brain surgery, where surgeons are operating inside the patient's brain through the help of a video microscope. So we're basically saying that we want the player to be the surgeon in the driver's seat, and narration will be the other surgeons standing by them, giving them instructions and feedbacks, because they also have access to the monitor screen as well. And obviously, we will keep iterating on our current build. So in addition to refining driving controls and camera angles that Jimmy already talked about, we plan to further investigate white blood cells' behaviors, like how they actually work inside human bodies, and then find a way to present that in our game. We will work on graphics and effects so that our game looks prettier, more polished, and we'll do more playtests along the way. So our current build has no sound in it. We'll add sound effects and narration dialogues in the coming weeks as well. And for the features we talked about but aren't in the build yet, we'll do those. Introduction and ending will be in the form of narration, and more new interactions just depend on what we decide to do with white blood cells and viruses. This is a timeline for the rest of our work. We will finish adding features by week 11 and use the rest of our time to do final playtests, iterations, and prepare for final presentations. And that's it for our presentation. Thank you for listening. We're now ready to take questions.
So, your game is in 3 dimensions, and your controls are a car-like interface, but that have very different behavior from a car, from what I could tell. In that, I heard at one point you said the forward and the backward pedal, and I was like, whoa, wait a second, cars don't have that. How transferable is your driving experience to actual driving? And could it actually, in the end, be counterproductive by giving people a kind of embodied sense of driving something that behaves absolutely differently from an actual car and potentially be dangerous? So if you're deliberately driving something but in a different way, that could cause accidents in the real world. Have you thought about that possibility, and what is your thinking in terms of how to control the vehicle?
So in our experience, the player is basically driving like a plane or a flying vehicle. So it's definitely very different from driving a car. And we know the device is almost just same as a car driving devices. And during our playtest, I think our playtesters were adapting the controller and the flying experience pretty well. So we don't think that's a very critical problem for now. It seems a little complicated, but if you are actually using the controller, it's pretty natural to drive. Yeah.
And I think there is a pretty clear line between our game and reality, because we set the clutch pedal not doing anything about clutching, it's about going upward. So we basically set the sense that you shouldn't be thinking this game as real driving experience. And also that based on our observations through playtesting, the players adjust, they, just like Yuxuan just said, they adapted to our controlling scheme pretty fast. And normally we found out that people are just using the clutch pedal for going up and the throttle pedal to going forward. That's basically what they get pretty soon. And many people often just, they don't really consider there's a huge difference between the backward and the normal brake pedal on a car. So I think it is something we should be also testing in the future to see how real drivers are feeling about this game, and it's the kind of problem that we'll keep looking into.
What is the goal of your experience? Is this an educational game about human anatomy, or is this more to do with the driving interface itself?
Well, I wouldn't say it's going to be an educational game about human body. It's more like creating a driving experience where we try to test how to make a difference between a normal driving game where you compete with others by driving fast, and turn that into a driving slow experience, which is the original title of our project, Driving with Care. And so I think we are focusing on trying to create a gaming experience where you intentionally control your speed and try not to drive too fast inside the environment. That is the kind of experience we are trying to deliver.
I'm just curious, you had patient health and vehicle health. So the vehicle takes damage from the white blood cells. I'm not sure how the patient health changes, but like if patient health is 0, is the lose state of your game narratively saying that the patient will pass away?
So as we just mentioned in the game, so it transferred from the rubber bands on the prototype. So if you knock down the rubber bands from the paper box, it will represent that the patient's condition just grow worse. So inside the game, if you drive too fast and bump into the wall, there is a velocity detection system that tells that you are driving too fast. And yes, it means damage to the patient. So we want to invoke this emotional connection between you and the patient so that you intentionally drive slow and try not to do that. So yeah.
That's time. Thanks, team.